speak since the pandemic on a non-Zoom occasion. I guess you can all, or many of you can relate. Well, let me get started. So the question I want to ask, or I want to present to you, is very simple. Is life a solipsism? I promise I'm not going to talk about Descartes today. All right, so classical solipsism. So there's different variations, but basically it all can be broken down to a sentence with a simple structure. Right? There's only one thing, for example, that exists, and that's the thing I have epistemic access to, and that thing happens to be me, right? Funnily, because there is this general structure, you can actually apply that to almost anything. In the case of biology, that could look like this. Biological solipsism, in that sense, would be the only kind of life of which we're presently able to form justified, adequate beliefs. Is the kind of life to which we have epistemic access to, right? And that's the kind of life we find on it. That's not something I came up with. It's something that a very interesting person said. And I'm always like, if people that inspire me and who I consider to be like some sort of very important academics in the field say something, I try to make sense of it. So Carl Sagan, in an essay, in a paper that he published, it's actually the introduction to this paper. He started, in our present profound ignorance of exobiology, life is a solipsism. There's no aspect of contemporary biology in which we can distinguish the evolutionary accident from the biological sine qua non. We cannot distinguish the contingent from the necessary. The time scale of evolutionary processes are so long that it's unlikely that such questions will ever be answered by terrestrial experimentation. For this reason, biology suffers from a deadening provincialism, an inevitable parochialism, like the physics of folding bodies before Newton. The deparochialization of biology can only come in the same way, by comparisons with examples elsewhere, by the pursuit of extraterrestrial life. Okay, all right, so I quote Sagan, or I present to you Sagan, because what he's talking about is commonly known as the N of 1 problem, which is somewhat the main topic of my research. And if you look closely, you can see that there is a case to make for solipsism that is independent of any sort of claim that, well, life just constitutes a single example of life. That's what I want to unwrap here. So how do we make sense of this? I'm interested in three questions today. What is biological solipsism, if anything? How to measure biological parochiality? And if in any way that's possible, how to deprovincialize biology? So my first thesis, if you can call that, would be we should reject biological solipsism strongly construed. So it asks too much from scientific justification. It's also too weak. It does not sufficiently explain what the parochiality of life on Earth consists of. I will present to you what all these things mean. Biological deparochialization does not have to rely on empirical access to life on other planets. Empirical access to life on other planets in and by itself is insufficient to deparochialize biology. So basically what I'm trying to show is, look, there are good reasons to believe that even if we had access to a manifold sort of life forms on many different planets, that would not necessarily qualify us to state that we're very close to a general theory of life or something like that. How we think of all these things, how we conceptualize independent evidence and so forth, matters very, very much in how we conceive of the inference problem to all life. So third, access to life elsewhere will certainly increase our understanding of life in the universe in rich and unexpected ways. But I'm fully endorsing that. I think everyone should. Like, if anything, like finding life elsewhere like that, I mean, we all agree, right? Hopefully, this would be just really amazing, frightening, probably, but amazing. But such discoveries do neither necessarily nor sufficiently correspond to biological deparochialization, which is actually like what Sagan has been concerned, or the whole kind of reason he is given for doing astrobiology. So let's reconstruct this a bit. So there's three kind of like mysterious terms: solipsism, parochialism, provincialism. Not really clear like what they mean here. I mean, I feel if you read Sagan's paper, it's more or less a metaphorical use of the word. It's a good approximation of what it means, but there's not a lot of clarity on that, because most part of the paper consists of actually trying to describe how astrobiology should be done. So, but we could say something like, well, life observable on Earth is a solipsism when it comes to life elsewhere in the universe, right? So there's the idea of, in order to observe life, we can do that so far only as far as we find it on Earth. We're limited empirically in some sense here, right? The parochialism would be to take epistemic consequences, to say that, well, what we can know or justifiably believe about life is really dependent on the availability of these sources empirically. And that happens to be just like the kind of life that exists on Earth. And the study of life, therefore, is just the study of life on Earth. So biology, in that sense, is provincial, as it says, right? If you take this to an extreme extent, you would maybe want to argue, well, really, our biological theories, they might apply on many, many different places in the universe, but justification-wise, we can really only safely say that they are valid on Earth. So let me summarize this. So there's the idea of solipsism. So biological beliefs are adequate, empirically adequate, if and only if they have been tested against biological sources. Seems to be more or less plausible. Parochialism, biological beliefs are justified only within the domain within which they are empirically adequate. So, right, no speculation in that sense, or careful speculation. Provincialism is more like a statement about the state of the science, right? Biological beliefs are valid only within the domain within which they are empirically justified. And globalization would be, in some sense, some sort of like outer goal, right, of biology, astrobiology, any sort of biology in that sense. We can deparochialize biology if and only if we extend the domain of biological sources. So in and by itself, so this position, I feel this position is not dependent on any particular claim that it is hard to generalize from life on Earth to all life, because life on Earth is just a single example. But this has been the main kind of way in which philosophers of science have discussed the problem of inference from life on Earth to life elsewhere. So what I want to do really here is to show that these two things are very different. Do we understand each of these views in and by themselves? When we say, I mean, I just like presented it something small, right? But what do they state really? How are all these views related to each other? I mean, can you just, for example, justify this without this, or reason for this without any of those? Are they really so mutually dependent? And this is the problem only when it comes to life, right? There's also the only civilization we know of ever is located on Earth. intelligent beings, art, whatnot, right? So what there must be some sort of like consideration of biology and life as something at some point in particular here to make this argument clear. So let's go to what I want to reject, or at least not reject, actually like cut, like a haircut maybe. Because I think that's the task, right? We should try to find the limits that we can, what are the best, what's the best worst case, right? Okay, so it's not just Carl Sagan who's written about all this. So J Simpson, famous evolutionary biologist, has called life on Earth a single sample, and has called this a problem for generalizations or inferences to other occasions of life. Ray has raised the idea that life on Earth is just a single instance of life, and therefore we should, you know, extend the kind of like domain source space of biology. Since we can't travel through the galaxy, he suggests we should just use synthetic or artificial biology. And then finally, Carl Sagan and kind of, or mostly Carl Sagan, I would say, have argued something like this, so that, but in order to formulate a convincing theoretical identity statement for life, we need a general theory of living systems. So this is a somewhat hypothetical deductive idea, right? You have a general theory, and the theory tells you what you can predict in systems, let's say planets, elsewhere, even if you have very, very little information about this system. It will tell you what you can robustly expect everywhere. So for Philipp and Campbell, this is really important, or this is really how they think astrobiology or any science should be done, if I read them correctly. This is really important when it comes to what they call a theoretical identity statement, which can be broken down to any kind of claim where you say like, this is life or this is not life, which is in the way astrobiology is often done, often inevitable, right? When it comes to confirmation. Often, not always. So, well, they say the problem is that we're currently we are currently limited to only one sample of life, namely terrestrial life. Although the morphological diversity of terrestrial life is enormous, all known life on Earth is extraordinarily similar in its biochemistry. But, and here's the catch, because these biochemical similarities can be explained plausibly in terms of a single origin, it's difficult to decide which features of terrestrial life are common to all life and which are not, which are just bottleneck effects, right? Inherited frozen accidents. So this problem, they claim, is not unique to life. It reflects a quote unquote simple logical point. One cannot generalize from a single example. So this analysis I call the strong case for solipsism. So the problem we have to solve when we ask ourselves, what can we infer, or how can we support hypotheses on astrobiological targets based on relying on life as observable on Earth? Every stance that claims that this problem needs to be analyzed in terms of what can we infer from a single example, I call strong solipsism. You might object to this term, if you will. Okay, so what I take it, they say roughly, or the idea is roughly to say that, well, on the one hand, you have this idea here about evidence. So empirical limits lead to limits to evidence, right? So it's just so and so much the data tells you. The limits to evidence lead to limits to inference, and empirical progress leads to epistemic progress, right? Finding more data, gathering more data. We all love that. It's awesome. And this is connected to the idea that, well, life on Earth represents a single instance of life. We cannot generalize from a single instance alone. Alone is very important here. So we have to gather. We have kind of like no alternative choice to gather additional instances of life. So I call this a standard analysis. So the main claim I would summarize as it is precisely because of the fact that life on Earth altogether constitutes an N of 1 that biological belief is parochial. Meaning it's only like justified to the extent we can qualify it as philosophical. So there are two claims I find particularly important here. Claim one is that if and only if we get access to independent additional examples of life, each equivalent to an N of 1, like an additional really example, we get to develop parochialized biological beliefs. So this is what we need to do, right? And secondly, only the parochialized N equals N biology is sufficient to be non-provincial. So some clarification. So the claim here is not to say that, well, life on Earth is an example of one, or the problem is, that we cannot generalize from a sample of one to life elsewhere, because life on Earth is like subject to this very unique special properties, or so that there's something special, extraordinary about life. That would violate the principle of mediocracy in one way or another, right? So rather the idea is to say that, well, anyone who would find themselves in a similar situation, that the only life they have available to them to study is the kind of life they have like on their own planet or environment or whatnot. Anyone would have to face the same kind of influence problem. So in a way, like the N of 1 problem is also something that should apply to aliens, given they find themselves in a similar situations, right? Maybe aliens who are surrounded by other aliens of different origins and whatnot in the faraway future, so they don't. But anyone who's like equal to us as observers should suffer from the same problems. Secondly, what's also really important, so I take this as a different claim from the kind of underdetermination problems we usually face when it comes to, extrapolating to a different complex system, right? So the argument is not, we cannot rely on biological sources on Earth to support predictions on astrobiological targets because we don't have access to the full information of all these idiosyncratic causal processes and whatnot on these planets, for example. It's not that we just don't have enough information, therefore all these problems. I mean, that's a point that is justified in and by itself, and that's a problem in and by itself, but it's independent from saying, because life is a single example, we cannot extrapolate, or we cannot do this, or we cannot do that, right? You would say something like, even if we had perfect knowledge of abiotics, of the abiotic information of some other planet, like a super screening of Mars, like 3D and everything, if you would then build on the kind of knowledge that we have on Earth in order to infer to what life on Mars could have been or would have been, or so, we would be equally justified if we had not this perfect screening. Okay, so I think there are at least 3 challenges to a view like that. First of all, you need to explain why it is that life on Earth, like collectively, constitutes an N of 1 such that it is parochial precisely because collectively it constitutes an N of 1. So you need to show, for example, okay, these are all the commonalities of life on Earth, and therefore all living beings are subject to the same kind of commonalities. And if these common features are like biased in one way or another, then our inferences are biased accordingly, right? That would be one way. And this actually, in fact, one way I will show you right away how people have done that. The second challenge is like you should explain how to identify equivalent instances of life, right? If you want to argue that the problem is not just a outright skeptical principle forever being the same problem, but we will really make progress by additional discoveries, right? You should at least be able to identify what these additional discoveries should look like, or in the sense that, I mean, given some sort of observation, what you should be able to do with it. What does it add to reduce the kind of uncertainty that you have, and to improve the process of deparochialization? Because otherwise you could just say like, well, it's hard to make inferences from life on Earth to life elsewhere, not because it's a singular sample, just because like there are many things we don't know about life, and if you find evidence elsewhere, that helps us in one way or another to disconfirm or adjust many biological theories. But that's completely independent of this claim about life on Earth being a single example. And the third challenge, I believe, is, well, you should also try to at least suggest or make plausible how this additional evidence should be aggregated. But my worry here mostly is that the universe is like, even what we call the observable universe, right? It's like incredibly big. So far, I don't think there's any really justified expectation that we'll be able to ever cross it to an extent to in situ study so and so many planets that we could say like, well, this is now what we usually consider quantitatively representative of all the planets and whatnot. Also consider it in terms of age. We're very early in the universe in some sense. So at some point you will always come to, any future astrologist will always come to this concern, like, right, is our data representative enough? Like what is the limit that we can kind of find out about life, like, or life as we, does, for example, life in like some sort of weird hypothetical form of life really exist? Like, what can we know if we've never observed it? Can we really believe that just because we observed so and so many forms of life that are not weird in that way, that this doesn't exist? Like, how should we earn this? Stuff like that, right? So of course today it's different. We're just struggling, or I mean, we would be pleased to find even one instance of life elsewhere, and I mean, who cares about the N of 1 problem? Then it's just amazing, right? If you have that. But in the sense of a global scientific project and the future of astrobiology, right? This might matter, or it might matter how we should think about this. So some questions. In what ways then does life on Earth constitute limited evidence? In what ways does life on Earth constitute a single instance of life? And how do these things relate to each other? Why should we relate these things to each other? Do the supposed limits to evidence, as found on Earth, entail a clear set of limits to inferences? Are these limits global / collective? So do they always concern all life, any biological thing, or are some limits just for some kind of biological observables, and other limits are just global? And can we overcome all these limits in a somewhat synchronous way? Does every additional discovery, or is there some sort of average expectation? Like, given 10 independent additional discoveries, we should more or less expect improvement in so and so much, or in this or that way, right? Open question. So 3 accounts of the N of 1 problem. So you read often of the N of 1 problem as a singular, as the problem. But in fact, like, if you take anyone's voice on it, like, equally valid, you find that people have, you can discriminate at least 3 different arguments that have been made. So one argument is just capitalizing on the unpredictability of macro evolutionary changes. You find this, for example, in parts in Simpson's paper 1964, where he argues that, well, exobiology is basically pointless, as he calls it. So the rough idea is to say that okay, anything biological you can analyze, or it really is an outcome of evolution. May that be a property, or it's like a biological form, or an individual organism, or a phenomenon, general regularity, right? So if you want to predict life elsewhere, it would be really cool if you could just like, use evolutionary explanation to do that. And then you argue, well, the problem is that obviously, since they are independent, you're not really sure or like how to do phylogenetic explanation, right? You cannot really argue that they share the same origins. So you're kind of like limited, arguably, as he reasons, to analogies. The problem then he brings up is that, well, we don't really have, on the basis of a single, like trial of evolution, a good understanding of what are robust analogies, like which things we will find, to which extent, in what way, for what reasons, under conditions that are alien to the conditions that we ourselves inhabit. Right, so it's slightly different from this thesis discussed broadly in biology, philosophy of biology, sorry, the radical contingency thesis, which in one way or another states that macroevolutionary outcomes are just generally unpredictable. So the difference is, and importantly, the difference is the reference to general unpredictability. If you believe, or if you buy into the RCT, you would say that, well, there's no matter how many discoveries of life we made, we believe evolution predictions are generally like just not justifiable. It doesn't matter, like there's no one problem, it's just like a problem, bam, right? So it's a stronger thesis, right? And it's differently motivated. But Simpson's, or this variation of the N of 1 problem, capitalizes on the idea that macroevolutionary outcomes are very unpredictable, or we should expect them to be generally very unpredictable, at least to a certain extent unpredictable, because of drift, and on the grounds of a single outcome, right? Our evidence is very small. You can also understand this in a different way. You can just take it literally as a statistical claim, an N of 1, like, when you talk about statistics. So the sample population represents the reference population as a united kind of instance. So you find this in some passages in Cleland, and you find this, for example, in von Werner. So the idea is to say, like, okay, there are good reasons to think that life on Earth constitutes a unified whole, right? Due to common chemical constraints, shared evolutionary accidents, a lost common ancestor, and so more, right? So due to this unity, whichever it may be, life on Earth collectively constitutes a single instance in a representation relevant, say, any inference from life on Earth collectively considered, so as a whole, to the whole population of life forms in the universe, or to what life is implicitly, right? Between the member and the population, is exactly like this kind of statistical inference. The problem in this respect is that on the ground of a single datum, there's like no real means to determine the error rates of our measurements, right? So, for example, multicellular life on Earth took like 2.5 billion years, 3.5 billion years, 3.5 billion years to evolve, right? So if you take estimates of that number, you don't know if that's like very typical or whether it's like on the edge of what's usual, right? And how this curve even looks like. But you had like additional data, then you could use more statistics, more and more reliably to do that. However, based on a single sample of life alone, we cannot generalize. And finally, so there's the argument about potential biases. I alluded it already. So the idea is that, well, unless we really have something to double check, where there are a lot of the things that we observe that are observably universal or general to life, to all life, unless we have this kind of like additional independent evidence, we're really just bootstrapping our way out of the equation. So we're really not doing something sound here. We can't really tell that this is reliable or this is unreliable, whatnot. I think all of these problems, they are valid and they're insightful and they're true to some extent, and astrologists have been dealing with them and are concerned with them in many ways. But when it comes to, arguing that all life on Earth is subject to this one very problem, I think there are explanatory troubles. So consider, for example, the following statement: all life, wherever or whenever it may be found, will be built from baryonic matter. And maybe some people argue, well, we should look for, I don't know, some sort of like dark matter-based life. Like, oh, could be cool, right? I mean, why not, right? So the point here is to say that, well, I guess most people would reply that, yes, of course you can generalize this, but you're not generalizing from biology. You can build it on the metaphysics of physicalism, right? That everything in the universe is supervening on matter, right? In that sense, and a combination of like no exotic chemistries, right?
Can you say what baryonic is?
Baryonic matter is the matter. I don't know the technical definition, but it's like the matter of which protons and
yeah, I think it's particles that we know of.
Yeah.
Yes.
Like,
so the dark matter is particles that we don't know of.
Yeah. For example, like neutrinos are not baryonic matter, right?
Yeah, they're kind of in between.
Yeah.
But we know about neutrinos.
Okay.
We know they exist, but the dark matter might be a
Yeah.
particle not yet discovered.
Yeah. And baryonics may be a detail here. The point is, right, you could also write atoms. So you don't need biology. You could answer like, this is just not a biological generalization. Well, it's a generalization about all life. So if you argue that we somewhat cannot generalize from life on Earth to all life, or like to all life, you kind of like should be able to tell what distinctively it is about biological sources then that renders all these generalizations as like impossible. Another trial: multicellular and mobile organisms will always eventually evolve camera-like eyes. I mean, it could be true, could not be true, right? It's like just speculative claim. But this is a claim that it does not concern life on Earth as a whole. Right? You don't need to, like, if you make observations or hypotheses about, what it takes for an eye to evolve, how an eye works, technically speaking, like as design explanation and whatnot. You don't need to refer to any sort of, okay, this is life. Life must be like this. Evolution must be like this, and so forth and so forth. You can just make some sort of a weaker hypothesis, and you don't need to deduce it, right? It's also something that you not necessarily would be able to deduce if you had a general theory of what are the universal characteristics of life. It's much more particular, right? It's inferring from camera-like eyes, creatures with camera-like eyes, to creatures with camera-like eyes elsewhere, or environments elsewhere, in regard to the possibility or the need to evolve camera-like eyes. Final example: most inhabited planets are inhabited by carbon-based life forms. Well, okay, this is like something that concerns all life on Earth, right? All life on Earth, as far as we know, is like based on macromolecules that utilize carbon. So generalizing it in the sense that all life, utilizes carbon for that purpose might be too much. But why do you have to? You don't always have to, use biology on Earth as a source for the like most general, most kind of like broad claims. You can be more modest, and You don't always have to invoke claims that have the kind of like utmost bar of justification, right? Weaker claims can be justified. So I think none of these accounts are able to explain what it needs to be explained in order to account for strong solipsism. So evolutionary unpredictability. So if it is sound, we're currently unable to make reliable predictions on the outcomes of evolutionary trajectories. Right. First of all, like that's not all that astrobiologists are interested in. They're also interested in other generalizations. Like, should we consider this to be affected by the same problem, or is this N of 1 problem really just about predictions of evolutionary outcomes, right? More importantly, so how could we deparochialize biology then? Replaying the tape of history on Earth would consequently increase our confidence on many outcomes, whether they're robust or not, right? Whether certain pathways or developments will repeat frequently. But that does not say very much necessarily on evolution trajectories that take place in different initial environments. So the question is like, okay, if we access the actual single trial outcomes on other planets, why should we consider this to be enough? Shouldn't be also, I mean, how representative of their own planet would we then consider them to be if we consider our things very, very underrepresentative? My point is not that, you know, there's like nothing you can say, but it's not obvious what you can say. You need to say more. It needs to be more clear what the worries and the expectations of improvement are. The account does not tell us anything about how many trials across what kind of potential contingencies we might need for a given expected progress in deparochialization. In terms of for the statistical and determination account, if this one is sound, we're currently unable to make any justified general claims about the distribution of biological properties across the universe, right? How much life is based on orbit, whatnot. So, however, it's kind of unclear what the reference of that population would be. It seems hard for me to make any, right? Either there's the problem that you could refer to any sort of definition of life to create a respective extensional reference population, or that you're just like being able to tell what this is actually the good qualifying here. So how do we measure a base rate, right? In terms of, okay, this is one example of life, it's an other example of life. A sample of what, right? So it's just some conceptual ambiguity here. Furthermore, it does not seem to be possible to assign error-adjusted priors. It's just very difficult usually. I mean, even on the grounds of the Copernican principle, we should always reason as if it was very unlikely that we were very untypical in more than a few respects, right? So it should be, even if you have like, okay, it took life on Earth roughly like 700 million years or so to evolve. Yeah, we're not really sure where to put this on the distribution curve, but should we put it on the edges? Like we can't contain the uncertainty, right? So finally, many inferences on astrobiological targets are not in virtue of life on Earth collectively, or in regard to life in the universe collectively. What about these inferences? In terms of the sampling bias account, well, really, I think that's the most exciting one because it's capitalizes a bit on epistemic paranoia, right? Where should it all end? If you're unable to identify all the kind of like candidates, then how are we able to identify all the relevant candidates if you find some form of life that's like completely alien to us? I mean, maybe they're subject to like idiosyncrasies we don't even know, right? So it's just something that, right, it doesn't reject the account, it just shows that things might be much more complicated and more particular and contextual. how you should think about this N-of-1 problem or this solipsism. So additional discoveries of life elsewhere should not anonymously allow to improve our confidence about potential biases, right? Like so for some things, like let's say you think, okay, all life is based on a left-handed chirality, right? You find life elsewhere. It happens to use some sort of like double helix, but not very unlikely to work, like as an example, and it's like right-handed chirality, or the macromolecules, the amino acids or whatnot are like utilized in a way that they are asymmetrical to all life on Earth. That's a symbol of this confirmation. You don't need more of that. Other things might need more, right? Depends on the hypothesis that you want to defend. So yeah, I believe that all these underdetermination problems are valid in and by themselves. They all present at least modestly different N-of-1 problems, each of which require at least modestly different solutions. Neither of these accounts are able to account for strong solipsism, though. This one. I thus recommend to drop strong solipsism, but where does it leave us? What should we do? So first of all, I think we should rethink like how these things fit together. To me, it's not obvious that they all require each other, that the potential interpretations of these terms like are necessarily compatible with each other. For example, it could be that we're like in respect to some maybe the materials of the solar system, right? That gives a clear bias in terms of from which materials life could have been built, right? So there are idiosyncrasies. How should claims and worries about idiosyncrasies be related to each other? How should we think that the discovery of life elsewhere will help us to improve on these uncertainties if we take these uncertainties serious? We always have the option to stay conservative and say like, well, we don't need to take them serious. It's not what I'm advocating. I'm just advocating, hey, it's not clear how we should think of this problem. I also think that there might be some potentially persistent problems. So one is very awkwardly, I called it very awkwardly just the problem of astrobiological contingency, which is really, I alluded to it, like how to identify all the relevant potential sources of biological contingencies, right? You go somewhere else, you find a similarity in respect of one property. How sure can you be, or how many additional such discoveries do you need in order to rule out that this similarity is not due to a bias that you're ignorant of, to a shared bias, right? So the same problem that basically scholars have applied to all life on Earth, I don't think it just simply goes away just because we have some kind of independent origin stories available to us. A really cool example in this sense, I find the rare earth hypothesis, right? It just can be roughly summarized as we will argue that not only intelligent life, but even the simplest animal life is exceedingly rare in our galaxy and the universe. We believe that life in the form of microbes or their equivalents is very common in the universe. However, complex life, animals and higher plants, is likely to be far more rare than commonly assumed. So let's assume for a moment that's actually true. In this sense, like if we studied microbes, we would be able to study something that is rather representative of, or that gets us maybe some easier access to life elsewhere. Or however, if we would study animals, we would study something that's much subject to many more idiosyncrasies, right? In fact, Carl Sagan has written one or two papers on this microbial idea. It's really cool. You should read it. So examples for evidence that they provide, Warren Browley, for their hypothesis For example, the overproportionally long duration of the emergence of multicellular life on Earth. So what you need is evidence to show that, well, we have good reasons to believe, based on the single example of life we found on Earth, that microbial life, is very frequent, but the other one is very, the complex life, multicell life is very rare. So you really need to relate those two base rates or varies. And typically long duration of tectonic activity on Earth. So the idea is something like, okay, because complex life we can expect it takes very long to evolve. Simple life, we can expect it doesn't. So most planets apparently have a less long duration of tectonic activity. Tectonic activity is really important for complex life in many, many ways. And we also have good reasons to believe that many microbes would be able to exist even after tectonic activity ceases, at least for a couple of millions or billions of years. Idiosyncrasies of the solar system, they also bring in as evidence, right? Our solar system is very untypical. We have this large moon and the Jupiter were like really good distractors of asteroids and whatnot. So to make life more Earth a more friendly environment for animal life, and untypical events necessary for major transitions to animal life, like endosymbiotic events. He also argued that this is something that's like just really unlikely to happen in terms of the mechanism. So what I take from this is like, okay, there may be some idiosyncratic conditions underpinning all biology observable on Earth. There also may be some that underpin only some biology on Earth, and there may be idiosyncrasies that underpin not just Earth. Right. And based on the single sample or whatnot, Earth alone, like there is an underdetermination claim to be made on all of these three levels. The second problem I call the problem of double bookkeeping. It's really tentative, not so serious, but it reminds me of bookkeeping and like how to account for all the transactions in a consistent way, so that you don't lose money or don't get thrown in jail. How did you determine ex ante, so before a discovery, what kind of evidential weight or informational value a given observation should add marginally as an additional bit of evidence, simply because it has been sampled empirically independent from life on Earth? How to evade or escape variation traps, so repeated confirmation biases. Carl Sagan writes about that also frequently. This fear that if we would do something like, let's say we find microbial fossils on Mars, and every potential similarity we take as a similarity, as some evidence that further adds to the hypothesis that these similarities are universal, right? If you keep doing that, you might end up just confirming what you already know. On the other hand, you might become more and more confident that there are no unconceived alternatives, that they become more and more unlikely. Two thought experiments, hypothetical examples, multiple origins. So imagine in the remote future, a group of heroic astrobiologists are able to access an inhabited Earth-like exoplanet in situ. And just imagine how long it might take us humans to get there, right? After an intense and exhaustive period of research, the astrobiologists are able to confirm that the many different living beings that we're able to study can be divided actually into two separate clades, each of which is the outcome of an individual origin event. It is not entirely clear to the astrobiologists how these origin events causally relate to each other and how evolutionary trajectories of these clades depend on each other. But they can confidently tell that only one clade includes complex life, further confirming their belief that simple life is much more frequent than complex life, right? Is this reasoning sound? What would you do as peer reviewers of a paper that argues this? So the question here, right, is it sufficient, or what happens? How should we count it, right? Should we really insist on the point we should count clades and origin stories, or should we count a shared evolutionary environment, a shared material basis that is to be found maybe on this planet or whatnot? Depending on how you answer on these questions, you will advise scientists very differently on what they should do. The kind of like complementary example of obviously is panspermia. So in the remote future, again, maybe even later, a couple of hundred years, a group of astrobiologists discover a star system with 2 inhabited planets. One of these planets they discover harbors complex life. Yeah. To their surprise, the astrobiologists find strong evidence that all living beings that inhabit the star system share a common origin. Like, wow, okay, crazy. So like 4 whatnot, different planets, all the same origin. The scientists explain the clades on each planet as instances of evolution from panspermia. Cool, we have an example of that, confirmed, awesome. A lot of new papers. They are not sure entirely, however, which planet is the ancestral one. They would love to know that. But as they believe that complex life must take much longer to evolve than simple life, they reason that the planet harboring complex life is most likely the planet on which abiogenesis took place. Right? In this case, you would say something like, we have established a certain, expectation to find complex life, and therefore we can exclude alternative explanations such as idiosyncratic events, for example, asteroids hit, asteroid disasters or whatnot that hit a particular planet and maybe therefore destroy complex life, stuff like that. Right? So again, like, what would you do? How would you peer review this? I mean, of course, it's a toy example. It's not like actually it's hypothetical, but I guess the point stands. So my suggestion, in light, what should astrobiologists do, or how should we think about astrobiology in the light of the N-of-1 problem or biological solipsism or whatnot? The first suggestion is this: okay, the justification of astrobiological inferences is not necessarily or not always assessed in light of particular yeah, we should assess stuff mostly contextually and in light of particular variables, not in light of, okay, something is part of a whole plate or something is part of a individual planet. Assessment of it, secondly, the assessment of evidential uncertainty of a given variable in regard to its marginal contribution to the total amount of evidence should be really assessed depending on the kind of inference that you want to make. Like, you should compare it not to how much evidence of similar observations of this variable that we have, but foremost, like, what kind of other evidence do we have to support the hypothesis, and where does it fit in there? And finally, the adjustment of inductive risk and meta-inductive uncertainty in light of contextually relevant and conceived alternatives. Also, I would argue, like, you should try to first and foremost determine in light of what kind of hypotheses and research contexts should we expect what kind of, like, plausible unconceived biologies, like really like potential errors of inference coming from life as we don't know it, instead of like just generally trying to, well, there's always some hidden variable, there might be some hidden bias and whatnot. Yeah, that's very abstract. Good, thank you.
Thank you, Philip, for a lovely and thought-provoking talk. And yeah, I'm not entirely sure if there isn't some teaching happening at 5. So let's assume we've just got 10 minutes of Q&A.